Good morning, everyone. Today we are going to explore a very interesting topic that was medical textiles. These are not ordinary fabrics. They are specially designed materials used in hospitals and healthcare for protection, healing, and rehabilitation. They must be safe, sterile, and biocompatible and comfortable because they come in direct contact with our skin or even internal organs. Examples include surgical gowns, wound dressing, bandage, and implant coatings. I understood that these fabrics play a major role in patient recovery and infection control. So, through this section, let us understand how different materials and design ideas make medical textiles both safe and effective. In the design thinking process, the first stage is empathize. Here we try to understand the real problems faced by the users. In this case, patients and healthcare workers. Imagine being in a hospital wearing a heavy, itchy gown or having a wound dressing that causing irritation. Many patients complain about discomfort, infections due to non-sterile fabrics, and lack of breathability. Similarly, doctors and nurses need fabrics that are easy to sterilize and lightweight and safe to handle. So in the stage we put ourselves in their shoes and think, what can we do to make medical fabrics more comfortable, antibacterial, and user friendly? After understanding the user difficulties, the next step is to define the problem. Here we frame our main question: how might we design a fabric that is biocompatible, comfortable, and antibacterial for medical use? This definition helps us focus on three main goals: reducing the infection risk, maintaining patient comfort, and ensure biodegradability. And the classification of medical textiles is three types. First one is based on the fabrics and the fibers and the types of structure and the areas of use. The types of fabrics or fibers based on the source of origin. It is a natural or synthetic. And then move to a biodegradability. Some medical textiles are the biodegradable in nature and some of the non-biodegradable in nature. And the types of structure, it is a non-woven, braided, and knitted, and woven. The area of use, the medical textiles are used in the surgical, extracorporeal, and health and hygiene purposes. And the medical textiles are used in the implantable medical textile and non-implantable. And also it is used in the healthcare and hygiene products, and some of the cases it is used in the extracorporeal devices. And once the problem is defined, we move to the ideate stage where creativity begins. In this stage, we brainstorm possible solutions using different materials. For example, chitosan based fabrics are great because they have natural antibacterial and healing properties. Silica infused fibers can provide extra strength and prevent bacterial growth, and natural polymer blends like cotton or silk combined with biodegradable materials can increase comfort and sustainability. I learned that the stage allows us to explore multiple combinations before choosing the best one for the product we want to create. And now let's look deeper into one of the key materials, chitosan. Chitosan is a natural polysaccharide obtained from chitin, which is found in the cells of and crabs. When chitin is treated with an alkaline substance such as sodium hydroxide, it becomes chitosan. With this, what makes chitosan special? Its natural antibacterial and biodegradable properties, and it is used in the medical textiles because of its safe and active nature. It is one of the most popular biomaterials in modern medical textiles. These are the key properties of the chitosan. And in medical textiles, chitosan can be used in several innovative ways. It can be blended with natural fibers like cotton, silk, or polyester to create antibacterial fabrics. It can also be applied as a thin coating on non-woven dressing to prevent infection. And another fascinating method is electrospinning, where chitosan is turned into nanofibers for wound healing applications. And let now focus on another interesting material, silica. Silica can exist in nanoparticle or fiber form, and it known for adding strength and thermal stability to fabrics. It also helps in resisting bacteria and odor, which is very important in hospital environments. Silica coatings improve durability and prevent microbial growth on surface. I learned that silica is also used in implant coatings and surgical drapes to enhance both safety and longevity. So when silica and chitosan are combined, the resulting fabric becomes strong, antimicrobial and long-lasting, perfect for advanced medical textiles. After developing our material concept, we enter the test stage. This stage is all about checking how the new textile performs. We test for antibacterial activity, breathability, patient comfort, and durability after sterilization. When we design a new wound dressing, we test in a lab simulations or clinical environments to see how effectively it heals and prevents infection, and realize that testing ensures that every new textile design is safe and reliable before being used in real medical conditions. And let's end with a quick challenge. Imagine you are part of the medical textile innovation team. Your goal is to design a new wound dressing for diabetic patients who often face slow healing and skin irritation. This question is, how can we combine materials like chitosan, silica, and PLA composites to create a dressing that heals faster and remains comfortable for the patient? Think. These are the references, and thank you. Have a great day.